Hello, and welcome to Cranfield University. In this interview series, we explore the role of philosophy and humanities more broadly for management, engineering, but also for our everyday lives. My name is Andrey Pavlov, and I'm Professor of Strategy and Performance here at the School of Management.
And I'm Toby Thompson. I'm the Studio Director here at Cranfield University. My principal interest is in executive education and the work of Martin Heidegger and the continental tradition.
And our guest today is Dr. Guru Madhavan, Norman Augustine Senior Scholar and Senior Director of Programs at the National Academy of Engineering in the United States. Guru, welcome. Welcome to Cranfield.
Greetings. Thanks, Andrey. Thanks, Toby.
Guru, can I just start with probably the broadest question possible? So you're an engineer. You're also a leader in the public administration space. You've got an MBA. But you have a keen interest in philosophy. Can you tell us a little bit about where this interest came from?
Perhaps in the kind of a recent historical sense, I had a crisis, and I think usually change often happens from crisis. And mine happened during the earliest stages of the financial crisis in 2008. I had just finished an MBA, and it was around February 2008 when I was reading some articles in the Financial Times and Bloomberg and so forth. And I couldn't quite understand what those articles were talking about, what they were trying to communicate, and what problem they were actually describing. And this is, imagine me being a freshly minted MBA at the time and unable to understand the rudiments of a crisis that had catastrophic consequences. So I semi-randomly applied for an economic policy fellowship in Washington, D.C., and lo and behold, I was selected to serve in that role at the National Academies in the fall of 2008, which had an interesting environment. It was a historic presidential election underway then, and then since I'm originally from India, I was paying attention to the India-US nuclear agreement around that time, went to quite a bit of hearings on the Hill in the Senate. And of course, I got to work with a former Treasury Secretary, and which proved to be a very influential step in how I constructed my next steps. So in a way, that kind of setting generated the more formal, kind of more grown-up interests, me explicitly seeking that kind of knowledge in philosophy. Of course, my own personal background, which we can get to, embeds quite a bit of philosophical dimensions in me. But I think this was the first time I went in search of kind of greater understanding of the world around me. And I think that was the time when I moved from being a freshwater engineer to a saltwater engineer, and how the worlds were completely different, yet I had to bring a very different kind of adaptive capacity, to use that evolutionary metaphor, to adapt, survive, even thrive in this environment. So I think after I moved to Washington, D.C., which is now about 15 years, I have cultivated the need to be more reflective. And I'm guessing we'll get to the concept of reflection in our conversation today. But I think that's where I got in, and it was a complete practical motivation rather than, let's say, an academic one.
And why philosophy, of all possible ways of kind of bringing the power of reflection into this? What is it about philosophy that caught your attention?
Who said this? It may very well be Aristotle, or let's just give him credit for this. I think he said philosophy entails success at the right times, on right occasions, toward the right people, for the right motive, in the right way. And viewed from an engineering angle, and I would also say right design. And however, whatever the word right is, and I think that's where the kind of the value debates begin to emerge, or to use more standard terminologies of like market pressure, customer requirements, or whatever. What does right actually mean? And that's where the kind of, as I mentioned, the kind of the freshwater and the saltwater kind of mixing, and it creates a very different kind of environment for organisms to thrive. That I found to be rich in volume in the philosophical traditions and literature. But of course, I've also equally borrowed from the historical insights and the sociological and anthropological insights. So in graduate school, I had to take a 4-credit course to fulfill certain requirements. And all the standard engineering courses that I would have normally taken, circuit design, electron devices, whatever, hardcore stuff, they were all sold out because they were all extremely popular in the engineering school. So I didn't get a seat in one of those classes, but I had to fulfill that requirement. So I got advised that I should just basically fulfill the requirement, take any course offered in the university. And I went and took a course on cultural anthropology. And they used to meet in the evenings. They had no assigned readings. The students and the faculty member would just sit in a circle and talk about issues. Therein came my first lesson. How do you do engineering this way? Because it was a very different kind of an engagement with a concept that I couldn't even tame or understand, or I was trying to grapple with. That's where I think the initial cultural shift happened. And that's where I think my interest in writing and kind of my own internal arguments about making sense of the world kind of slowly started simmering. And I think in Washington, it got to a boiling point where I formally needed to rely on philosophy, history, sociology, anthropology to make myself a better engineer so I can contribute to the wicked policy problems that are in front of us.
You don't seem frightened by philosophy. I think some of the people watching today might be frightened by philosophy, thinking it's a whole big discipline. But you mentioned your background there. I'm very intrigued, hopefully our viewers are. Say more about your background, where philosophy comes to the front.
Yeah, so the philosophy is not intimidating for me intellectually because, and please forgive the engineering bias or the engineer speaking here, and I used to work with quite a bit of medical imaging and medical devices and so forth. So for me, it is not that different. And again, I hope philosophers take this in a friendly fashion. It's not that different for me than a microscope or an MRI scanner, because it is allowing me to get a greater understanding into the system that I am trying to engage with, or even potentially intervene, not control, because most of the issues that we are thinking about are not controllable in a philosophical sense, or even in a public policy sense, or even in a public values sense. So that's why I think it provides, paradoxically, a resolution, because some of my colleagues get frustrated that philosophy is often confusing, it's often in the realms of abstraction, and engineers don't operate in that way. And that's where I don't openly disagree with them, but I think that needs to be changed to ensure that engineering and philosophy are well integrated, because both can and do operate very effectively at various levels of abstraction. But of course, that's, I think, part of the answer here. My own personal upbringing, I was born in an Orthodox Hindu family in southern India, and my grandfather was a temple priest in our village, and I still have the habit of getting very early up in the morning, something that I've retained since my childhood. That's mainly because he used to get up early in the morning, and some of the earliest influences, because he had to go open the temple, and the farmers going to their daily jobs would stop by the temple and then go. And so I used to assist him. I was a soup priest at the temple. And similarly, in the evenings, they would reopen again, the farmers coming back home. They would stop and everything. That, I think, gave me some early philosophical inclination. So in that regard, by nature, I'm philosophical. And by culture, I'm philosophical, not necessarily with a degree in philosophy.
Some could say naturally, given that background, you're a philosopher, but I'm just an ordinary Joe, and I couldn't possibly do philosophy. I guess you'd say, yes, you can. You just start asking questions.
I guess so. Yeah, I guess so. And I think it gets back to the identity part. I mean, okay, I can borrow quite a bit from philosophers and poets even. But it's sometimes difficult to argue that in a technical engineering meeting where you're arguing trade-offs and costs and schedules with a bunch of engineers. I think now how do we, again, gets back to some of the promising pathways that we have here. How do we explicitly incorporate the philosophical dimensions into the engineering design process so that we can be more reflective in addition to being more effective? I think we are not there yet. We are not there yet. I think that there's still a big cultural chasm, so to speak. Although they're appreciated, those ideas are appreciated, but it's not openly discussed.
So what is it exactly do you think that philosophy could bring to engineering, that could contribute to engineering? What's missing?
Well, explicitly speaking, and I think we have mentioned this before, so let me get a little bit deeper into this, which is how do you take a more measured, nuanced, and engineers do this, measured and nuanced approaches anyways, even systems approaches. I think that's kind of in the culture, but a more reflective tradition of design in kind of negotiating the pressures. Philosophers are excellent at this. They negotiate, I mean, of course, they think in paragraphs, speak in like, pages. Engineers may not be that comfortable with that kind of rhetoric and rigor in the argumentation. And I've even gone to conferences where philosophers read their papers, stand there, and whereas in engineering it's just whiteboard and pen, and so it's a very different kind of culture. But that's just the day-to-day practice, kind of a superficial comparison here. But of course, the negotiating the constraints even of what different visions exist for a particular widget even, and what process does one undertake to achieve that? And these are much deeper questions because we now live in a time where technology development is now in a generic sense much more comfortable for us than before. Sure, the financial infrastructure needs to exist, and the policy infrastructure needs to exist, and the market needs to exist to produce and promulgate a technology. But I think the vision setting, or the kind of the procedural dimension, not necessarily in an instrumental way, but in an insightful way. Also, how do you reconcile the different powers, and I literally mean that, the different powers engineers have and engineering has in many different domains of our life. We have not thought about that, and that I think also links to how, if someone misinterprets those powers, and it could distort the professional responsibility. And we have done that in the past, and that's often because engineers work in corporations and they receive tasks, they have orders, they have contracts, which is not necessarily the case with, let's say, other people who are also confronted with constraints in various aspects of life. But in engineering, the practical consequences are enormous, whether it affects generations of people or whether a company goes bust without getting another contract, which means job losses and then impact on economy and so forth. So that's that. And ultimately, so let's see, we have discussed 4 items here. First one is, I think, negotiating the pressures. The second one is kind of the vision setting and the kind of the procedural dimension of engineering. And we talked about reconciling the kind of the different powers of engineering and engineers, and how we should prevent those powers from distorting the fundamental professional responsibility. But I think they all lead up to what we are now talking about, a just world. What does it actually mean? I know jurists and legal scholars have a very different perception of that. There's certainly philosophers. Engineers haven't gotten to that yet. I think they're too busy in the kind of the day-to-day nitty-gritty. At least that's what I can tell of many of my friends and colleagues here. And I think this is where the kind of the idea of a just world should not be about a well-lived life, it should also be a well-examined life. And it's the latter part that's not helping, because there are tremendous claims about, and of course, factual evidence that engineering has altered quality of living, extended lives, even in a material sense, in a monetary sense, in a biological sense, but not in a philosophical sense.
Wow, this is almost like a program of philosophy, the whole program of the philosophy of engineering in there. There's so much to unpack here. I really like your idea of, I suppose, the profession of engineering and the discipline of engineering, asking the question about justice and the just world, and the life, the kind of life that we should live. But could I take you back to your conversation about the powers of engineering and how they can conflict and how they could be misunderstood? Can you talk a little bit more about this?
Let's explore the kind of the intellectual dimension here. And I wrote about this in my previous book. I tried to popularize what it means to have an engineering mindset. It was, of course, a difficult task, and I boiled it down to 3 essential ingredients, which is, and again, you can note these elements to, have kind of links to power here. The first one is the ability to see structure where there's none. Of course, we all do that, but one of the things that I was taught early on as a junior engineer is how do we, and this was kind of in a course on strength of materials, a civil engineering professor taught it, and what he told me I'll never forget, which is about imagining a bridge across a river connecting 2 surfaces. And most people can do that, and artists can do that. Monet did that in many, many paintings, clearly or unclearly. But what he was trying to say to me was, how do you visualize the stresses and the strains on the load-bearing columns of the bridge? It is as if to imagine the weight of the world on your shoulders before even such a thing existed. Now, that's what has been referred to as the mind's eye in engineering. And I confronted with the mind's eye with the kind of mechanical drawing, because I think I was in the last cohort, one of the last few students who took mechanical drawing as the kind of the sole way of training. And then, of course, the cohorts after that entirely went into computer data design and but I think I had the advantage of mixing both of those things. But there's something about drawing, literally the pencil and the drafter, mapping out the stresses on a paper. It is a very different experience. And I think that's where it gets to the kind of the artistic tendency here. I mean, like kind of almost like an impressionistic image where you feel there's something there. There's some cloud here, and then there's this Westminster behind it. There's some vague action going on here. Now that's there too, but in engineering, you really have to materialize this sooner or later. And you're usually running behind schedule when it comes to large projects, and you're running out of money. And the managers are asking what's going on. So it's a very different kind of constraint, which I think is the second aspect of the engineering mindset. Invariably, it's about designing under constraints. Again, it applies to life as well. But as I just mentioned, cost, schedule, technical requirements often dictate a traditional engineering process. You just don't have one. And as the saying goes, pick 2 of the 3, because it's engineering is not able to. So what I'm trying to say here is it is a sacrificial profession. You're always giving up something, which ties in very closely to the notion of trade-offs. Now, what are you willing to sacrifice, and what are you willing to pay for it, and what are you willing to accept for it? You can see the kind of the philosophical connections there, but the only thing is we just don't ask these questions out loud, but they're usually computed or in the form of some code or some equation. But again, they convey different messages here. Trade-offs, of course, you can't weight versus strength and so forth. You can't have everything.
Toby and I are now going to fight about who follows up on your question.
I want a question.
Just a quick follow-up, if I may, Guru. But just to kind of play devil's advocate for a second, coming from a management school, you could say, well, yeah, but the economists have sorted this out. They'll give you an understanding of the trade-offs, and they will give you an understanding of what, or a rule or a criterion about how to make that decision. And so, why ask questions that are more abstract and more philosophical than that? Then,
I think Adam Smith asked about this, right? In 1776, he wrote about the diamond water paradox, which is like, what is the value of a product or service, whatever, in its use and in its exchange. Diamonds are pricey. They have very high exchange value, not necessarily use value. But water, of course, has enormous use value, very little exchange value. Now, this kind of economic theory that you're talking about, so this kind of relates to some of my current thinking, current writings, even how the 19th century French engineers, I think it goes even to the 17th century, but let me just focus on the 19th century, the early 1800s and so forth, and then one of the école systems in Paris, where engineers became very the kind of the priests of the social arithmetic. And this was the time even before the word scientist was developed. I think the word scientist came up in the 1830s or so forth. So engineers were responsible for public planning, and how they confronted these kind of economic questions in practice. Now, how do you create a waterway? How do you create a water supply system in the city of Paris? And how do we go about charging for the roads that the wealthy use? It's basically a horse buggy kind of thing. So the kind of this preferential cost, differential pricing, those kinds of things that now we talk in economic terms, engineers confronted them way back in very practical dimensions, and they had to grapple with the philosophy of tariff setting in the literal sense. For example, Navier, the famous Navier-Stokes equation, whose equations are now used in aerodynamics, material design, and basically fluid, anywhere you have fluid flows, all the characterizations, had his engagement with these kinds of public policy matters. Same with Jules Dupuy, and I think he was the one who more actively confronted these matters. And I think he's one of the lesser known economic heroes. He basically founded the modern theories of microeconomics, as we now call it. And several Nobel Prizes have been given based on his practical work to economists decades later. And I think it comes down to a very powerful word that economists use: utility. What does it actually mean? And I think this is where utility, some people, and I think you can see economists also have commonality of optimizing under constraints. And you can see a significant flow of engineering concepts into economic theory. But I think there was one point where engineers just maybe have given up on these in a kind of more intellectual or academic or theoretical way. But they encounter this all the time. An example I've written about relates to, early 2000, the city of Stockholm was facing enormous traffic congestion, and of course the people there prioritized quality of life more than other attributes that are important to them. For example, they didn't tolerate the significant delays in commute, and I think it was affecting one thing or another in their daily lives. So they went and complained to the city council, saying that this is just not acceptable. So let's think of something else. And of course, you go to some committee, and the engineers are coming and saying, yeah, let's maybe build another road, maybe another bridge. Now, that's the kind of standard mentality, which is to increase capacity. It also makes economic sense. And you can actually plot what the use consumptions are. But that's where the Stockholm City Council got a little bit more creative and went and brought in an unusual group of consultants. They were actually systems engineers from IBM, a company that didn't really have anything to do with infrastructure, roads, or standard civil projects. The systems engineers come and they go about, again, this is early 2000s, right? So they plant transponders, like hundreds of thousands of them. They take photographs, and then they go and measure the dimensions of side streets, parking lots. They even did something that engineers are still shy of doing. They actually talk to people, what's important to them. And then they spend about 6 months efforts, and then they build a complete systems model. And then comes a recommendation that they take to the council, which is, you're not building another road, you're not building another bridge. Instead, what you're going to do is start charging people to use the roads when the demand for the roads is at its highest. Now, charging for something, a service or a commodity, when the demand for it is at its high, is not new at all. This goes back to the barter system. We have just practically experienced that. But then, of course, that led to a technological breakthrough, which is kind of the camera-based tolling system that we see in every part of the world. And I can go 65 miles per hour on the Dulles toll road here without even having to slow down for a mile. And then the thing picks up my tag, and then I automatically get billed. 15, 20 years ago, people used to go to the local 7-Eleven and pay on a monthly basis what they actually use. So now it's all completely automated, and the technology is much cheap, high fidelity. But this is where the economic concept comes into your question of. Now, I sometimes pay $25 each way. I think that's what they're charging now, easy about $20. On the Verrazano Narrows Bridge, when I'm trying to go to New York City on the New Jersey Turnpike, if I just go a few miles north, there's a George Washington Bridge that charges, I don't know, 12 or 15 bucks or whatever, almost certainly cheaper than this. And the return path is free. Verrazano is 25 or whatever each way. And if you have a much bigger vehicle, like tractor trailers and so forth, you pay even hundreds of dollars to go there. But that is primarily for convenience. It is contingent on how much value I attach to my time to get to my location. And that is a complete personal preference. And this is where I think Jules Dupuis said in the 1800s, it's all extremely reductionist way. Well, utility is what people are willing to pay for. That was basically it. He encountered the same question, which is like, should we make the water tariff prices flat, kind of the equitable pricing back then? It was defeated. Because they say, well, some people use more, some people use less. So I think we need to charge people differently about this. So this is where the kind of the preferential design really complicates engineering. And I think in economics, we have the concept of price sensitivity. I mean, what is the threshold to which you get to, beyond which you may not be willing to pay and everything? Would I be paying 50 bucks each way to go across Verrazano Bridge? I remember the time when I used to pay $12, but now, so my threshold is going up and everything. This is where psychology and the kind of the economics and the engineering design really occupy a messy nexus here. This, of course, has philosophical dimensions here. How should we think of price and cost? The concept of fair pricing has existed since antiquity, right? Now you can apply the same thing to prescription drugs in the United States. With COVID vaccines, we manufactured them, gave out free. But then, of course, there's also profit linked to the manufacturers there. And it's also publicly funded, I think. And that's where I think these kind of messy dimensions force us to ask, to answer your earlier question, Andrey, which is like, what kinds of engineering we ought to be doing?
Got a good question.
No, please.
I was going to ask you, Guru, but I've just been listening and observing you. I was going to ask you, how does an engineer think? Because I know you've gotten books. You've got Applied Minds and How to an Engineer Think as books on Amazon. But I think what you've just done shows how an engineer thinks.
Or should think.
Yeah. Well, I was going to use the word should. And then in one of your books, and I forget which, I'm afraid, you talk about multidisciplinarity, multicultural, and multinational. Is what we're talking about here, is the way that you're demonstrating to us right now, the thinking that you're thinking, is that a global thing? Or is that purely a Western, higher education, National Academy of Engineering thing?
Well, we're trying to articulate a much kind of a global conception, maybe a broader way of thinking and living and designing through our programs at NAE, which I'll get to. But I think the Toby, what you're asking about is like, we are all overstimulated with the kind of information, data points, whatever you want to call it. But I'm more worried about the opposite, which is, so that's the topic of hypocognition, which is how our competencies, even capabilities, are limited by what we can conceive. This is where I wish, I think philosophers have, it's very rich, and especially the really good ones, they're able to marry the clouds and make rainfall happen. But I think the concept of hypocognition is really profound here, because as I said, it's very limited by what we can conceive, which is the tendency to unthinkingly apply familiar, very comfortable pet frameworks to the world around us, even if they're completely inept and irrelevant.
Indeed.
Now, so the example for this is like, it's in the early 1800s, Americans tried to introduce ice blocks in the island of Martinique. Those people didn't know what to do with it. They didn't know what to think of it. They just left it there to melt. There are a lot of ice blocks around us that are just melting, and we are not using them. That's mainly because we are completely fixated in our freezer, inside our refrigerator, which makes us happy and gives us comfort during the summer months or whatever. But I think there are a lot of insights in the history and the philosophy, the sociology, the anthropology of engineering that needs to be brought out for kind of public consumption, argument, and debate. I'll give you kind of since I'm just on a flow here, it relates to, there's a profound book that came out, I think it was in the early 1970s, Edwin Layton, he wrote the book, Revolt of the Engineers. And he talked about how engineers were struggling to carve out an identity for themselves, which was largely hinged on the kind of the industrial vision of technocracy, largely manufacturing driven. So this is, again, he was reviewing a time period, 1910, 1930s, I think a 20-year period, maybe that generation. This was when mechanical engineering was the kind of the dominant force, the civil engineering maybe before, but again, that's pretty superficial to say that, but I think it was mechanical engineering that primarily motivated such questions of kind of the efficiency movement and so forth, and how companies were utterly devoted to driving business development, and engineers felt that they were just servants of the corporation. And what were the efforts, the struggles engineers took in those 20 years is what Edwin Layton talked about. Now, fast forward to 2012, another book comes out written by Matt Wisniewski, who's a historian at Virginia Tech. And he talks about a 20-year period, 1960s and 70s, where engineers go through a similar kind of frustration. So it's almost like a cyclical frustration once in a while. So maybe we are now coming to that in the 2020s here, but that's just to your point, how do we think about it? But the 1960s era, of course, was largely focused on discontent, malcontent relating to Vietnam War and what kinds of technologies we ought to be building, what does social responsibility mean, and what are the negative effects of engineering. And again, engineers are talking about this. It doesn't come to the forefront because they're not out there publishing, talking at conferences, but I think these are just professional, practical frustrations that engineers are going through. But I think the engineering societies at that point are fairly evolved, much better than in the early 1900s. So I think they take on some of these issues, and outcomes from those frustrations, what we are now calling about, okay, public understanding of engineering, public appreciation of engineering. Many of the outreach efforts that are underway to say that engineering is viewed subservient to science, but I think it can also create sciences and even a predecessor to science. And so those kinds of broader explanations and so forth. And so that's underway, and I consider myself and my colleagues as contributors to those efforts. But what would be the kind of the equivalent, or is it happening now? I can't quite tell. What is the kind of the contemporary unrest from an engineering standpoint is something to think about. I don't know, or maybe we need to be better informed about this, because you can see there are people who are simultaneously developing online technologies that we don't fully understand. They have a very different kind of character that they're developing, very different than what, let's say, engineers are taught in ethics courses. How should a person behave in a situation or two? So largely situational ethics, microethics, so to speak. But now we have in our hands technologies that themselves gain character. They do some strange things that we don't fully understand. So, which I think is the kind of the broader question of that's where the ethics becomes kind of a social responsibility, cultural responsibility kind of question. So we are trying to tease those questions out, at least at the National Academy of Engineering. And our entire programs are based on 3 words, deep themes, each of them: people, systems, and culture. Now, when we started talking about these things, and initially people were intrigued by this, what does it have to do with engineering? Because these words usually don't get attached to engineering. But I think within seconds, they, yeah, of course, make complete sense. But we are trying to focus on, okay, we have done a really good job focusing on engineering for people, systems, and culture. Now we need to start focus on the people, systems, and culture of engineering. How do you make engineering itself a more welcoming field, bringing in broader participants? We have been exclusionary in the past, but that's just not tenable going forward, given the world that we are living in and the consequences we are creating. And that's why, there are engineers who are phenomenal, fantastic. They work in some incredible firms, developing social media technologies, online search technologies, and so forth. At the same time, there are a bunch of engineers who also are developing technologies to block social medias because it's affecting how we think about the world and so forth. So you have simultaneous efforts underway, which I think has always existed, but now I think we can see it, we can feel it much more than the historians who I mentioned earlier tried to struggle and capture it in their books.
We are born free, but we are everywhere in chains. It sounds like some of that censure is us as engineers, maybe. We don't allow ourselves. And it sounds, you're a kind of a Renaissance man here. You are open to pretty much everything. But you seem to be asking a lot of the engineering educator too, because they also need to demonstrate what you're demonstrating to us now. What advice would you give to engineering educators that are thinking of revising their teaching methods or looking at halfway through their midlife crisis? What am I doing here? What's your advice?
Fairly basic here, because the theme of problem solving gets attached to engineers and engineering very often, so much so that it has become the prime identity. I'm a problem solver, I'm an engineer. And I've seen it in t-shirts, everywhere, hats, everywhere. Sure, we have done problem solving. I've personally been remunerated, compensated, gotten bonus for problem solving for the work that I did in industry or elsewhere. I think most engineers find that. I think that's integrated to the profession. But making that as an identity, I think might be limiting or limited, because we have to think about, and this is where the kind of reflective dimension emerges, what does it actually mean to solve a problem? Or should all problems be solved? Or are there other means of engaging with the problem? And are numbers the only way to define how we solve a problem? What about words? And now philosophers are very good in the words. I mean, of course, Wittgenstein has done a thing or two. He was a former engineer, and it's amazing how people like him have just gone on. I can't even understand some of the paragraphs he's written. I've tried talking to some philosophers, and the language game, I buy it, get it, the spirit of it, but I cannot get through his book. But something deep, burning is residing in those words that I think we're still trying to figure out what he may have meant. Similarly, I think from a naturalist perspective, John Muir also worked as an engineer, and he went on to a very different path, trying to improve ecological awareness and so forth. Now, none of those people really had the kind of the education that we are now subjected to. So something has deeply changed. And I know my colleagues, many engineering educators are working toward bringing in a richer, broader perspective of how we think about problems, even the hierarchies, the class structure within problems, and what's acceptable as a solution, and what's marketable as a solution, and what's ultimately effective as a solution. We need to have those kind of fundamental discussions, I think, instead of just saying engineers are problem solvers, let's go change the world. Now, that's, I think itself, it's a very reductive tendency to present ourselves. So this is where I'm hoping we have more reflective conversations on this subject. I know a lot of people don't tolerate these kinds of ambiguities. Fine. They're busy doing what they're doing, and they're very good at doing what they're doing, and they're doing some incredibly important things. But some of us have to do it, I think, so that these conversations get to the kind of the fore.
You're doing it.
And so would you say, what is the practical, or what are the practical implications of working out the answer to this question, to the question of what is the modern identity of an engineer?
Let's not equate technology to engineering, please, because that's like saying a spreadsheet is an economy. Mm-hmm. Now, that's where it is. I mean, engineering is one of the oldest acts of humanity. It's probably one of the earliest acts we created. It was created by choice because it tied to our survival and trying to kind of make sense of the world, tame the world back then when tools entered it. And I think in that regard, philosophy, the philosophical dimension, were also as old as that. I mean, is it fair to say that the philosophical consideration led even to the concept of democracy? I don't know. I've not thought much about it, but I'm just thinking out loud of governance structures over time. So if that is the case, then engineering is even far older than democracy as, let's say, a governance model. But engineering is also politics by other means, as the saying goes. So engineering was manufactured, created with these political goals because it seemed like an effective instrument to achieve those. And we are still doing that. We don't talk about it in this way, but I think pretty much everything and anything is linked to engineering, from jobs to health to economy to stock markets to hailing an Uber ride, everything connected. So now I think we need to, it'd be useful for colleagues to even really comment on the evolution of art, almost like an archaeological dimension, right? Much of it is not even written. And we talked about the Indus Valley civilization during the prep session and how those systems were actually built and for what reasons. I'm a big fan of the Chola temples, the great living Chola temples in South India, and they're all from 9th, 10th, 11th centuries and so forth. Those temples weren't just built for the value of divinity or worship. They were structures of social capital. They brought communities together. And I think this was a kind of the cohesive element that engineering played. That was not technology the way we are now interpreting it. Something has changed. When did a largely sociological force turn into an economic one that's now appearing as a technological one? I need guidance to think about these questions. Maybe my questions are ill-formulated, but you can see where I'm going with this thought process.
And what do you think the kind of feats of engineering in other cultures could give us? What can we learn from them?
I'm particularly interested in this. I mean, I know much has been written about this, Andrey, and instead of me trying to summarize it in a way, of course, Asian engineering and of course the Roman engineering and in Greece, and how those structures, almost impossible sounding structures, were built and so forth. But I think that's something that one can readily relate to. Okay, yeah, that's hardware, that's a structure. You can actually see something material. However, the kind of the prehistoric bridges work and the water supply, I think there's quite a bit of historical work in there. But I'm interested in knowing how, and this is what I think Harry Collins calls the interactive expertise. How did teams congeal to think about something like this to be built? And what kind of expertise developed in action? Now, that is, I think, a very different kind of expertise than what we are now describing expertise as. I think one has to specialize in something, and I think we'll see where the synthesis is possible after. But no, I think the kind of the synthetic dimension preceded specialization, the way I'm trying to interpret history in my own limited way. So I'm interested in the kind of the interactive elements. Did the Asian cultures do this differently than, let's say, the European or the African and the native traditions? Many of them, those engineering works have been unwritten, undiscussed. And I think we need to tell those stories.
How does all this, what you've talked about, which is amazing, tie into your everyday work at the National Academy of Engineering?
So thank you for asking. This is something that I'm very fortunate to be contributing to. My job is to work with some of the most brilliant people in the world, and every day I learn from them. And as I talked about the themes of the National Academy of Engineering programs are people, systems, and culture. And our programs are deeply interlinked to that. We have a program called PEER, Practices for Engineering Education and Research, which really looks at the complete spectrum from what they call K through gray, the complete spectrum of how engineering is taught, processed, perceived, applied. So largely engineering education related portfolio. A second one relates to, we call it CSER, the cultural, ethical, social, and environmental responsibilities in engineering, which is interested in some simultaneously very technical questions, such as how do you develop technical solutions, even standards for indoor environments where we most of the time live, and what they mean for ensuring air quality that we need to survive, to defining what does it mean to have good character in engineering design. So that's kind of the breadth of that program. Another program is an outreach effort, what we call IDEA, Inclusive, Diverse, and Equitable Engineering for All. And one of the highlights of that program is to get middle school girls get interested in engineering. So in a way, we are expanding those successful efforts broadly into the youth outreach area to get them interested in engineering, excited about engineering, and consider engineering as a career pathway, and link them with the potential mentor. So it's a complete outreach program. A similar outreach program relates to bringing early and mid-career engineers and kind of mix and match their thinking, who are at the cutting edge of their research in industry and universities and government. And it's an international program called the Frontiers of Engineering. And finally, we have a new program called Focus, which is the Forum on Complex Unifiable Systems, which is trying to engage with the wicked systems using the kind of the systems engineering practice, philosophy, and management, broadly put. I think the most famous study that's often cited in systems engineering is, of course, the Apollo project. So much has been written about it. And of course, it involved the coordination of tens of thousands of people, millions of taxpayer dollars, and kind of all coalesced with the national vision of achieving a goal safely. Now, that worked for Apollo. Now, many people have tried to adapt aspects of that, let's say loosely call it a command and control approach, which is to other parts of public policy. It doesn't necessarily work that way for housing policy or urban development or infrastructure policy and so forth. So how should we be thinking about successful systems engineering efforts to these other facets of public policy? Not an easy question at all. And therefore, it innately requires us to go beyond the engineering, the standard engineering sensibility, so to speak, to bring in those perspectives so that we can broaden our understanding of the problem sets rather than getting too busy with delivering solutions that may or may not work even within a particular context. So that's the kind of the organization that we are working on.
Mm. Guru, could I bring you back to something that we discussed earlier, but also build on something that you've just said. In many cases, when we think what Toby and I, lay people, think about engineering, we think of kind of big things. We think of design, we think of the Apollo project, but I'm fascinated with the part of your work where you look at the issue of maintenance and the kind of the role that the task of maintenance plays in the engineering profession. Toby and I had a chat with David Goldberg as well, and he mentioned your concept of the grind challenges. And can you tell us a little bit more about this? Why is this important? Why is this important to engineering? Why should we be talking about this?
It relates to how we are captivated by the sizzle of something. And I think it relates to our human psychology. We are captivated by something that is grand. I think there are some deeper benefits there because it helps mobilize action. It sets bold targets. Countries are aiming toward something bigger than what they're individually capable of, or maybe a consortium of nations, like in climate treaties and so forth. But too often we get carried away by those grand dreams and desires to the point of forgetting, under-recognizing, even under-investing in the dull, mundane things like care and maintenance. Now, if you look at the philosophy of care literature, so much has been written about it that I'm trying to make sense of this, because this is where the parallel track, as we were talking about, the kind of the philosophical understanding of the world and the kind of the engineering of the world have parallel tracks here. So I think one just has to look at it as if it's kind of a musical counterpoint. What's available in this harmony and what's in this harmony, and together they create an altogether different effect, so to speak. So I think in that regard, there is a fundamental misconception that maintenance is, of course, it's a chore. It's boring. Who wants to do it? I have to do trash at home and clean up my car, whatever. I mean, I think we all do maintenance in a routine way. But we have created a parallel, maybe a contrasting concept that has taken on greater importance in society, as if it's an act of marketing. And that's how it feels to me, which is the excessive importance of innovation. Of course, it is deeply integrated to the engineering thinking, but I have issues when it actually overshadows the other gentler, subtler, kinder acts of care and maintenance, repair, refurbishment, renewal, all those terms that actually, in fact, if you look at the root word of innovation, it comes from repair and care. So it has now come to, and I think part of it, since I've been through business school, I've been subjected to literature on this topic. The notion of disruptive innovation is too powerful. I mean, it's too captivating, and it's ready to invest. Who wouldn't want to change something and so forth? But I think it is the kind of the daily grind which enables gargantuan acts like the Apollo program that need to get greater recognition, because without maintenance, I mean, the entire civilization crumbles, collapses. And that's what we are trying to debate, even at least in the US infrastructure policies here. I mean, it's very easy to give an award to a person who built the bridge, not so much to someone who retrofitted a bridge. And I think we need to think about the politics of recognition there. And that's where it was a play on word. I just changed one character in grand challenges, and it gives me a completely different meaning. So so how do you get, it's actually the grind that leads to the grand. And I think as I'm getting older, I'm less interested in the sexy parts of engineering, but more vexy parts of engineering.
Very Derridian. I like that point. As you're talking, Guru, I'm loving that counterpoint metaphor that you had, the music metaphor, but I'm seeing philosophy differently, just based on this conversation. That philosophy is actually of this world, and I'm seeing that just from what you've said about engineering. Tell us more about what inspires you. Where do you get your inspiration to think more along the lines you've already demonstrated to us?
It's primarily conversations like the ones we are having, of course, but I work with some incredible individuals. So I'm mostly interested in knowing what they're frustrated about that they're not talking about. So that requires a little bit of a mind reading and extensive listening. So I think that's that. But of course, I attend professional conferences and talk to foreigners and strangers who are very different than my professional preparation, and I've always found the value in those conversations. So it's basically trying to stay in the moment is what I try to keep it very simple. I have nothing sophisticated to offer there in terms of how I develop ideas.
But what are you reading at the moment? What books are on your desk? What's on your intellectual radar screen?
I'm currently less on the reading mode right now because by the end of this month I need to deliver my finished revised manuscript of production. I've taken about 6 years to write a book on wicked problems. And I was just telling a friend the other day, saying that with all these large language models, the GPT models that have come, I hear that they can write an entire manuscript in 6 seconds, yet I've taken 6 years to work through that. But the question now is like, would the algorithm know what kinds of books to read or what kinds of people to talk to? And I think that's the kind of the hands-on work. And again, it goes back to my professional training, where I think I was in the last cohort of manual drawing, or it says something I can click on CAD, which I can do as well. So I think it's just one of those things where I feel like every sentence is constructed bespoke for this narrative. And Toby, that actually the book is structured in a counterpoint format, and that's why I use that metaphor. There are 2 tracks in the book. One relates to the politics of recognition, how we recognize some individuals or the others, maybe even at the expense of others. And that kind of has tie-in with even the innovation and maintenance theme that we were talking about moments earlier. So that's one track. It's an aerospace narrative. And again, I was motivated by something I knew nothing about, take on something completely foreign, teach myself, and then produce a manuscript on it. The second one is like, okay, how do you deal with wickedness? I mean, you can approach it from an engineering way or a philosophical way. I think wickedness has a lot of writings and concepts, at least in the Hindu tradition, Buddhist traditions. Of course, you're a monk, you know that, and so I think how do we separate our thinking from what could potentially become wicked, or what if it's already wicked now? How do you get something positive out of it? Something interesting. But of course, the book doesn't get to that level of philosophy here, but I'm trying to see what are the essential concepts that one might fruitfully apply, because we all might disagree on the problem formulation, even the solution, or resolutions. But I think in a conceptual level, I think we have greater scope for agreement. And I'm talking not just about people of different political parties, but even people from different academic departments in a university. So I think these are kind of general purpose concepts that I had to do. So I've had fun kind of integrating those two narratives. So that has kept me occupied, and of course I had to read quite a bit of it, quite a bit for it.
I suppose I have one last question for you, Guru, and it's probably just as broad as the question I started with. You have been thinking about these ideas for a long time, and you have been working in this space for a long time. What's your view on the general interest in the philosophy of engineering and the philosophy in engineering? Is it growing? Is it stable? Is it declining? Are more ideas coming up and more people are being interested in this, or what's the dynamic of it? What do you think over time, over the years?
I really hope it grows much faster and much bigger. I think it still remains small. You had mentioned David Goldberg. Of course, he's a pioneer in this area, and I have a really good friend, Zach Pirtle, who's at NASA, who I think has been a tremendous influence on my own thinking. But I think the community that's interested in, or at least actively engages in these issues, is still small. And I'm talking about hundreds of people, if that. But people who are in the kind of the main domains, there, of course, they largely outnumber these small communities. So someone like me, I have to go in search of these kind of communities that might not be readily visible to others. So how do we at least bring visibility to these communities is something that I'm interested in, and I'm hoping we can do a better job at. Because the moment people are aware of it, they at least think, okay, you can go to a technical conference or a sociology conference. Of course, tens of thousands of people attend them. But these little conferences, or even little symposia or workshop, or the journals that they publish in, very small ones, I think contain deep insights, and that shows the struggle. Invariably, whatever the blockbuster idea is, or a disruptive idea is, it invariably comes down to kind of the broader functioning or the functionality of the available domains that I think, feed into these smaller communities. How do we do that? I mean, that's a complex question, because it is so easy to specialize in anything these days. How do you live and thrive as a systems practitioner? It's an open question. So that's at least what motivates me. Maybe I should write more about this, or think more about this, or bring these concepts to some of the meetings where, in some cases, the ideas or the solutions are predetermined. They just need buy-in, or they are very quick to jumping to conclusions. I think it's okay to slow down a little bit, kind of insert a meaningful inefficiency in our process, which I think, much like a speed bump on the road, or a stop sign in the road, or deliberate slowing down, it's all there for a reason. Engineers did the studies. That's a whole nother area, how transportation systems came in. I mean, why would they want, bulk of the discussion should be get faster to your location versus get safer to your location, which is, I think, in that regard, I think I'm more interested in the getting safer to your destination, even in terms of public policy issues. And that connotes the responsibility, which has, I think, undergirded the entire conversation that we have had today.
Well, Guru, this was a really inspiring conversation certainly for us,
Yes.
for Toby and me. And thank you so much for sharing your time and your insights. Let's keep the connection going.
Thank you so much for the opportunity, and especially for allowing me to free flow here. So really appreciate the opportunity, the conversation, and the platform.
This has been a real education for me. I've learned something, so thank you so much.
Pleasure, Toby.
Thank you
Thank you very much, Guru.
Thank you.